So we've spent some time talking about the ways that we can collect data. So now let's focus on the types of data that we can collect themselves. It's worth pointing out at this stage, by the way, that data is a plural word. It's singular, one piece of data, people tend to say, but it's singular is actually datum. You talk about a single piece of datum or many pieces of data. Anyway, let's have a look at this. So data is split into two different overarching groups. You can either have qualitative data or quantitative data. And those are really hard to say quickly. So qualitative data is the kind of data that is associated with non-numerical observations. So qualitative data is non-numerical. So if you ask people questions on their opinions, that's qualitative data. If you want to find out about people's hair colour or eye colour, anything like that is qualitative. So colours, opinions, and I'm sure you can think of plenty more. Now, what we tend to focus on a little more is quantitative data, because you can do a lot more analysis with this type of data. So quantitative data is numerical data. There's all sorts of types of quantitative data. Something like shoe size would fit that category, but also something like height or age or weight, all sorts of other things, and I'm sure you can think of plenty more. Quantitative data is split into two further subcategories. So the first of these subcategories is discrete data. So a variable that can take only specific values in a range is a discrete variable. Now, by specific values, I mean, for instance, if you are counting up the number of pets you have, you would have 1 or 2 or 3 or 4, but you wouldn't have 1.78 pets. So it can only take fixed values. In that case, it can only take positive integer values. So we've got discrete data takes specific values in a range. The other type of quantitative data is continuous data. And continuous data can take any value in a range. So let's take something like the time it takes athletes to run the 100 metres. Time is a continuous variable because you can keep measuring more and more accurately, and it doesn't have to be 10 seconds or 11 seconds or 9 seconds. It could be 9.56 seconds or even more accurately measured. So time is a continuous variable. Height, weight, all those things are continuous. Generally, you can consider continuous variables as those that can be measured, and they can be measured to particular degrees of accuracy. So these are, let's call them measurable variables. Discrete variables, let's go back and get some examples for those then. Something like shoe size would be discrete because you can be a size 4 or 4.5 or 5 or 5.5, but nothing apart from or in between those particular values. So you can generally think of discrete data as something that is countable rather than measurable. Those aren't particularly robust definitions, but it helps you to kind of get your head around the difference between them. So we've got discrete and continuous. Discrete is specific values, continuous is any value within a given range. Now, when you've got lots and lots of data, very often you want a way of presenting it so that it's easier to manage, because if you just have a long list of numbers, that can be very hard to see. It can be very hard to start to visualise and to start to conceptualise. So one of the first ways that we present data is in a frequency table. So I've got an example here from the book of a frequency table, and this one is measuring. You will find that the examples in this book tend to be really rather bizarre, but this one is measuring the length to the nearest millimetre of the forewings of male adult butterflies in a random sample, as you do. Obviously there'll be somebody somewhere in the world who does this, but there we go. Now, you can see how they've grouped these four wings into these four wing lengths into groups here. So 30 to 31 millimetres, 32 to 33 millimetres, and so on. Now, this type of data is continuous data because we're talking about the length of something, and the length of something can take any particular value, which means we've got a few problems with this table. One, for instance, would be the fact that we've got these gaps between the end of this group and the start of this group here. Now, before I go any further, let's think about some proper wording for these groups. These groups are called classes. So this is the 30 to 31 class, this is the 32 to 33 class, and so on. Now, the limits of the classes are called the class boundaries. They're the maximum and minimum values that belong in each class. So let's come back to what I mentioned about gaps between the end of this class and the start of that one. Actually, this class doesn't really go from 30 to 31. This class goes from 29.5 up to 31.5. And then this one goes from 31.5 up to 33.5. And by filling in these gaps, it gets around that issue of the fact that this is continuous data. So it could take values in between, say, 31 and 32. But there's still a bit of a problem here, and that's that the number 31.5 is in both of these classes. So if a particular male adult butterfly had a four-wing length of 31.5 millimetres, which class would you put it into? So you have to decide whether or not you're going to go into the lower one or the upper one. And that's just a matter for generally taking a judgment. What we tend to do is we include a measurement in the class. So a 0.5 would go in, 29.5 would go in here, so 31.5 would go here in this group. So it's not included at the upper end of a lower group, it's included at the bottom end of a higher group. So a better way to write this would be with inequality notation. And we could say this group goes from 29.5 inclusive up to 31.5 exclusive. So then this group goes from 31.5 inclusive up to 33.5 exclusive. We can do a similar thing for the other groups here. So a measurement of 33.5 would be included in this group, but not 36.5 because we don't have the equal to part on this inequality here. And in this one, we've got 36.5 up to inclusive up to 39.5. Now, once we've decided what the classes really look like, we can talk about things like the size of the classes. That's called the class width. So let's make a little bit of an addition to this table, an addendum here. So we've got the class width. And the class width of this one, it goes from 29.5 to 31.5, so that's a class width of 2 millimetres. This one, 31.5 to 33.5, that's also 2 millimetres. 33.5 to 36.5, so 3 millimetres. And 36.5 to 39.5, so that's also got a class width of 3 millimetres. Now, the other thing that's going to become useful to us in our calculations soon is being able to identify the midpoint of classes. And the midpoint of a class is simply the mean average of the lower and upper bounds of the class. So something like this, it's obvious. You can see that halfway between 29.5 and 31.5 would be 30.5, but they're not always obvious depending on the size of the class. So just to show you what you would do if it wasn't obvious, you're going to add together 29.5 and 31.5, and you're going to halve it because you're finding the mean of them. And that gives us our midpoint of 30.5. So this one again, that's obvious, 32.5. Let me show you with the third one so you can see how it works. 33.5, add 36.5 and halve it. And that gives us 35 in the middle there. And similarly here, we've got 36.5, add 39.5 and halve it, giving us 38 in the middle there. Now, let me point something out to you as well. If you look at the original classes as they were presented, you can see that these midpoints here are also the midpoints of these. So halfway between 30 and 31 is 30.5. And come to this one, halfway between 34 and 36 is 35. Now, if you stop and think about it, it's obvious that that would be the case because we have gone 0.5 down from 30, 0.5 up from 31. So because we've gone the same distance down from the lower end, and the same distance up from the upper end, we're not going to affect the middle at all. So you can also work out the midpoints of these classes by using the original values that you were given, even though you must remember that those aren't the upper or the maximum and minimum values or the upper and lower bounds of each class. Now, you are asked in this question to state whether or not length is, first of all, quantitative or qualitative. We're talking about length. It's a number, so it's quantitative. You're then asked to state whether or not length is discrete or continuous. So we know it's quantitative. It's not discrete because it doesn't take specific values. It must be continuous because it can take any value. Anywhere between 29.5 and 39.5 could be referenced in this table. So it's continuous data. And then part B, you're asked to write down the class boundaries, midpoint and class width for the class 34 to 36. So its boundaries are 33.5 and 36.5. The midpoint we've already worked out. We added those together and halved it. So let's put NP for midpoint, and that is 35. And the class width we've already worked out. That's 3. Let me put my units back on there because all of these measurements are in millimetres, so it's really good to get in the habit of always making yourself put units on so that you can always think about the data in context, because data makes no sense without context. A number on its own is not helpful. A number in the context of what you're trying to analyse can be particularly helpful, so it's very important to keep on top of that. Now, there's one more thing I want to point out to you before we finish this video. Two more things actually. The first one is make sure that you're happy with what this frequency table represents. What we have here is there are 2 butterflies whose wing length measured between 29.5 and 31.5 millimetres. But there were 25 butterflies whose wingspans or wing lengths went between these 2 values, and so on. So overall, in this table, there were 70 butterflies. That's the total frequency. 70 butterflies whose forewing length was measured. So this table represents a list of 70 numbers. We don't know exactly what those 70 numbers were. So these 2, they might have both been 29.5, or they might have been 2 completely different numbers within this range here, but we don't know. So you'll see how that's important in one of the later exercises when we come to talk about working out estimates for things like means, because we don't actually know what they were, but we know there were 2 of them within that range there. Now, the only other thing I wanted to point out is that you can actually use your calculator to work out some of these statistics, things like mean and median. I'm not going to go into it in detail now, but in the next video, you'll see some examples of how we do that. So now you know enough to try exercise 1D.